The Earth is a beautiful and complex planet, home to some extraordinary and precious sights. But over the last few years, scientists have become increasingly convinced that climate change created by mankind has the potential to alter our world forever. The driving force behind Earth's climate is energy from the sun. Energy travels from the sun in the form of shortwave infrared radiation. Some of it doesn't get through the Earth's atmosphere, but lots of it does, and it's then absorbed by the land and the oceans and warms them up. The Earth re-radiates the energy back in the form of long-wave infrared radiation. But gases in the Earth's atmosphere, called greenhouse gases, trap some of that radiation. They act like an invisible insulating blanket around the Earth. This effect is perfectly natural. And if the greenhouse gases weren't there at all, global temperatures would be 20 to 30 degrees centigrade colder than they are now, probably too cold for life on Earth to survive. There's a delicate balance between how much energy reaches Earth and how much is returned into space. If the balance changes, it has a profound effect on global climate. There have always been natural variations in climate, since long before humans evolved.
The climate system varies naturally over many millions of years, over many thousands of years. If you think back to what it looked like when the dinosaurs were around, very hot, lush, tropical vegetation. Over the last 2 million years, we've seen changes that have really been driven by how the Earth and solar orbit varies. And we get periods when we get less energy from the sun, and occasionally periods when we get more energy from the sun. And that variation takes place over 100,000 years. Also, where the actual continents lie, the continents move around over many millions of years. That can also gear up how warm or how cold the planet is.
Other factors affect how much energy we get from the sun. For example, when volcanoes erupt, they can blast huge amounts of sulfur dioxide gas into the atmosphere. There, a chemical reaction creates tiny particles, known as aerosols. They reflect energy from the sun, making the Earth cooler. Everyone agrees there are lots of different natural factors that affect the Earth's climate. But some scientists have argued for many years that mankind is also having an effect.
Our planet now is really different to how it looked 300 years ago. For a start, the population now is much bigger. The world's population today is about 6.5 billion people. 300 years ago, that was only about 650 million. There's so much more technology around today. There's been the Industrial Revolution. We've used all these fossil fuels. We're now completely reliant on them to carry out actions in our everyday life, to heat our home, to go to school. All these different things require fossil fuels.
In fact, 3/4 of the energy we use in the UK comes from fossil fuels. And fossil fuel use is a global issue too.
Another, what some may see as a problem into the future, is that rapidly developing countries like China and India, they've got really big populations that are rapidly increasing. And all these populations, all these people, they're going to naturally want to have the sort of lifestyle change that we've had. They're going to want to swap their bikes for cars. They're going to want all the domestic appliances that we've sort of got used to and that have made our lives easier.
When fossil fuels are burned, they produce a gas called carbon dioxide, also known as CO2. The human race is now producing quite incredible quantities of carbon dioxide, over 7 gigatons a year. That's more than the weight of 1,000 million male African elephants. Carbon dioxide is one of the greenhouse gases that are found in the atmosphere quite naturally. But for some time, scientists have argued that all the extra carbon dioxide produced by burning fossil fuels is making the insulating blanket around the Earth too effective. It means that less energy escapes back into space. Instead, the trapped energy heats up the Earth's climate, producing climate change. Other things that humans are doing have also increased the amount of carbon dioxide in the atmosphere. Until recent times, a lot of the Earth's carbon dioxide has been absorbed into plants and trees as they use it to make food during photosynthesis. It's been an important way of keeping carbon dioxide locked away instead of up in the atmosphere. But all over the world, forests have been cut down to make way for farming and for towns and cities. The biggest tropical rainforest in the world is the Amazon in South America. It's the same size as Western Europe, but huge areas of it are being cut down every year so the land can be used for agriculture. And there are fears that the remaining forest is increasingly at risk of drying out.
As it dries, it's becoming warmer. As it becomes warmer, the trees can't live and they're dying off. That will just release more carbon dioxide into the atmosphere and speed up the rate of climate change as well. We need to really stop the loss of the forest to make sure they can act as some sort of buffer on the amount of carbon dioxide that we're pumping into the atmosphere.
There are so many different factors involved in climate change that it's hard for scientists to predict exactly how much global average temperatures will increase in the future. Just for example, the scientists can't predict how humans will behave. Will we be prepared to cut back on our use of fossil fuels? Or are we too addicted to our current way of life to do that? What scientists do know is that even small temperature changes could have very big effects on the planet.
If we look at the ballpark figures for how much temperature change there will be over the course of the next 100 years, it'll be somewhere in between 2 degrees to 6 degrees Celsius warmer by the end of the century. That doesn't sound a lot. We experience temperature changes of 10, 20 degrees just by walking in and out of rooms. But if we look back on what's happened in the past, there's no period in human history where the temperature has changed by more than 2 degrees Celsius in the space of 100 years. So even the bottom end of the estimate, 2 degrees rise in temperature, is still a profound change, and it's a rate of change which is unprecedented as well.
These scientists are in the Arctic, carrying out research on ice thickness and movement. The different factors involved in affecting climate interact with each other in complex ways, and climate change scientists are particularly interested in processes known as positive feedback mechanisms. These are processes that are triggered by climate change, which themselves then produce further changes, amplifying the effects of climate change. One example is in the polar regions, where there are vast amounts of ice. Ice reflects a lot of the light that reaches it. This means the ice stays cool because the energy is not absorbed. But now, because of climate change, there are large areas of the polar regions, like here in the Arctic, where there is less ice than there used to be. Instead, there's just open ocean. The dark ocean surface absorbs a lot of the light energy from the sun, which warms up the ocean, and that in turn helps to make the planet warmer. That means it's less likely that ice will be formed, and so the oceans will absorb more energy and become even warmer. It's interrelationships like these that make climate change a complex and important field of study. And it makes it vital that scientific research is accurate and well thought out. To achieve this, scientists have a special way of working.
When scientists undertake science, we carry out research projects, and then we write those projects up as scientific papers, and we submit those papers to be reviewed by other scientists. and they have to pass what we call the peer review process.
The peer review process means that research can be published only if other scientists believe the research is good and valid. Dealing with climate change, or trying to avoid it, has the potential to affect the way we all live our lives. We need a good understanding of reliable scientific research to help us make well-informed decisions about what to do.
Climate change is increasingly being seen as a moral issue, and not only as one that's scientific. I mean, there's a lot of scientific research that's gone into climate change, but increasingly the decisions are political. It's not necessarily, how much doubling of CO2, carbon dioxide, is going to affect global temperatures. It's about how are we going to get people to cut down on their carbon emissions. And in this country, we might have the technologies to do that, but how exactly are we going to be able to do that in developing countries? Is it fair that we necessarily say to them they've got to cut down on their carbon emissions when they haven't had this path of development that we've had so far? Is it fair to them to say they can't have these things? It's all quite a complicated political issue.
Decisions on these issues will have huge economic and social consequences too, and that makes them controversial. Some people claim that climate change caused by humans isn't happening, or that the role that humans play in changing climate is tiny compared with the impact of natural forces.
Some people might want to disbelieve what scientists are saying. Some of these people might be scientists themselves, and their jobs might depend upon having a particular point of view, so they might not want to change it. Other people, it might not be as well thought through as that. It's very hard to change your behaviour, and I can understand people saying, oh, I'd much rather think that climate change isn't a problem, and then I don't actually have to give myself these choices.
Recognising how controversial and important climate change is, the United Nations set up an international organisation of scientists and governments called the Intergovernmental Panel on Climate Change, or IPCC. In 2007, the panel reviewed thousands of scientific research papers that had already been peer-reviewed and approved by scientists. The panel concluded that most of the increase in global average temperatures since the mid-20th century is very likely due to the increase in greenhouse gases generated by humans. In other words, we are affecting the world's climate. The IPCC also said there is plenty we can do to avoid the worst effects of climate change and save much of what is precious. The question for us all now is, what are we prepared to do about it?